Hello, and welcome to the fourth and final session in our Automotive Electronics Roundtable series, sponsored by Murata. My name is Katie, and I will be your Globalspec moderator, and I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window, and anytime during the presentation you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I'd like to introduce our moderator for the Automotive Electronics Roundtable series, Edgar Sauter. Edgar is the Senior Director of New Product Technology at CSA Group. His team looks to the technology horizon for new developments and applications that could present opportunities for CSA's test, inspection, and certification business. To read more about Edgar today, please look at the speaker bio window right next to the main presentation window. And with that, I would like to pass things along to Edgar to lead us through today's discussion on the technology behind automated driving levels 2+ and 3. Edgar, the floor is yours.
Thank you, Katie. I am Edgar Sauter, Senior Director of New Product Technology for CSA Group, and I will be the moderator of this panel. We are very pleased to have you here as we put together this excellent group of experts and engineers in the automotive industry to discuss a topic that is reshaping transportation at a disruptive pace. With us today, we have Peter Els, who spent 15 years working as an engineer in South Africa's automotive industry, and now he writes about this topic for several publications. We have Warren Smith, Director of Perception for Insight LiDAR, who brings a wealth of sensing and processing experience and knowledge to the table. And we have Pekka Kostiainen, who is a Senior Manager of Business Development for Murata. In this role, Peter supports OEM and Tier 1 suppliers in their measurements, integration, and manufacturing efforts for automated driving. So Peter, Pekka, and Warren, thank you very much for being here today and share your experience and knowledge and ideas with the audience. Level 2+ and 3 automation is transforming mobility. New advancements are creating more freedom for drivers to do other things while on the highway. Today, we'll discuss how this technological evolution promises to change the driver experience forever. But before we begin, let's take a time to acknowledge our sponsors for today. Murata is a worldwide leader in the design, manufacture, and sales of electronic components, sensors, Wi-Fi and Bluetooth modules, communication components, and power supply modules for the mobility market. Murata is an established leader, innovator, and key contributor in driving advancements that help shape the industry's future. They continue to pave the way by fueling the evolution of mobile experience. The future of mobility relies on technology, and that technology relies on Murata. For more information, visit murata.com. This webinar is hosted by Globalspec, the world's largest online engineering destination for product sourcing and information. So having said that, let's jump into our discussion today. And I want to start with a simple question. We're going to talk today about level 2+ and 3 ADAS. So let's first talk about the differences. What are the differences between those two levels?
Edgar, I'll take that one.
Thank you.
Okay, so I think the best thing is to always revert back to what the standard definition is that's widely accepted on the 6 levels of automated driving, which is the SAE definition. And if you look at level 2 functionality is the vehicle can brake and steer, but only assist the driver. The driver is in full control all the time. Example of that is lane keeping or adaptive cruise control. Level 3 is very similar, but under very specific conditions, the vehicle can in actual fact drive itself. But the driver needs to remain engaged with the vehicle and ready to take over if the conditions change and the functionality moves outside of the vehicle's scope of operation. And an example of that would be the traffic jam chauffeur. Maybe the question is obviously, are these levels, are the definitions good enough for the consumer? Does the consumer understand the difference? Does he understand the nuance between driving the vehicle all the time and being ready to take over a vehicle that is ostensibly driving itself?
Got it.
Maybe to continue just a few words from that. So the current L2 systems, so the OEMs are highlighting that they are, level 2, so drivers and control. It can be confusing in the future when level 3 cars will be available, but that's also kind of legislation topic, education topic. But in the end of the day, when you can enjoy driving on highways and the car is doing that for you, it should be rewarding.
Perfect. Now, is that already considered autonomous driving, or we are still far from consider level 3 autonomous driving?
I think if we look at, and unfortunately, I think Tesla is always a case that's always going to be studied. By virtue of the fact that there are so many videos posted on YouTube of people falling asleep and being driven home by the car, and people just not driving the car and the Tesla driving itself. So I think in most cases, a vehicle like the Tesla at this point in time, now ignoring the edge cases, and I think that's what catches them out. But I think under normal day driving conditions, I think we are not too far off, of getting a vehicle to actually drive itself. But to do that safely, reliably, 100% of the time, I think that last 5% is what's really going to take a lot of time and a lot of effort. I don't know how you guys feel, Pekka and Warren? Edgar?
Let's say there is the vehicle technology, but there's also the legislation. So currently the kind of level 3 legislation says that it's related to automated lane keeping, and it's for highways and for maximum speeds of 60 kilometers per hour. And this is now how Germany will go forward. 60 kilometers per hour is not a very high value for consumers, so 120, 130 should be the target, but probably that will be the way to go. But that will be one kind of factor which needs to be taken into account.
Just to tie in with you, Pekka, I think the Audi A8, which was advertised as being the first commercially available level 3 vehicle, I think that is restricted to highways, and I think it's got to have a median wall, and I think something like 40 kilometers an hour that kicks out at 40 Ks.
There are strict limitations, and those need to be more reasonable so that those functionalities will be interesting from the consumer point of view. 40 kilometers, 60 kilometers, that's not so convenient.
Correct. Now let's jump into the legislation a little bit after. I just want to check something with you, because what you're saying is true, Pekka. This is a really important factor. But before we jump into that, doesn't mean that we have the technology today to do more. And that would be a question for you and for Warren too. Like, does that technology exist today?
Yeah, this is a good question. And it gets muddied in the horse race where we try talking about pretty abstract words like autonomous or self-driving. Even the L levels are not quite precise enough even for the developers. and they're certainly just flat out misleading from a consumer perspective. That really needs it needs us to go to their vocabulary, not to continue drilling into them our vocabulary every time we discuss it. Now, in terms of technology development, we have made an incredible amount of progress in the last few years, right? Both Waymo and Cruise are currently picking up and dropping off passengers with L4 vehicles, right? And so, given that definition, there are certainly operational domains such that L3 and L2 could be better, right? Now, that doesn't mean that you can go to your dealership and buy it today, right? Consumer vehicles require automotive qualifications and retooling of factories, as well as careful work needs to be done about those operational domains, cost, and those kinds of realistic things. But the technology has really progressed. And so I think you get into a little bit of, when would you say cell phones became a reality, right? You could certainly argue that the car phones, right, of the late 80s and early 90s fit the bill, right? But they didn't really affect everyone's lives. In the mid-90s, me and my friends, we still had pagers, right? And it wasn't until the early 2000s that you really started getting flip phones. And then the iPhone didn't come out till almost 2010. What was it, 2007, 2009, something like that. And I think we're seeing a similar thing, right? It isn't in a day. In many ways, we are meeting the qualifications even of the definition of full self-driving today, and that technology exists. But there's still a lot of work to deliver the impact of self-driving into day-to-day lives.
Then there's also, let's say, regarding robotaxi use cases. So those are typically limited to certain areas. So it's not like anywhere. And then there are, let's say, trucking application. So there's huge progress also there, but then that's focusing mainly on the highway. So kind of for level 3 for consumers, you need to be able to do it on highways, city areas, various conditions. And that makes it difficult, especially when it needs to be affordable.
Yes, completely agree. And as you look at these different products, I think you'll see different roadblocks to delivering those benefits and different approaches needed to solve them. So, like, one way to think about the state of autonomy software today is that given really good sensors, and by really good today, interpret that as expensive, right? Given very expensive sensors, we can solve what we call the perception problem. That is, looking around the car and identifying where everything is and what it is. That is largely a solved problem today. And in some applications, such as highways, that is, in fact, almost all that you need, because it's a very structured environment with very clear behavior rules. Where robotaxis are struggling right now to expand that operational domain that Pekka is talking about is more in the prediction and in the interactions or motion planning. That is, being able to answer questions like, does that person intend to cross the street, right? If I speed up, will that person slow down, right? And these are part of the difficult questions, I think, that are still being solved today from a science standpoint. So lots of engineering challenges. And from a software standpoint, from a hardware standpoint, the reality is we've got camera that's just about as good as it's going to get, right? There's some improvements. We could add thermal. We could do event cameras. There's some things we can do there. But for the most part, cameras there. Cameras are very mature tech. Radar could be improved for sure, but that's not really going to make the difference. I think that from a hardware perspective, the real key that we need in order to deliver a lot of these benefits are higher performing LiDAR, that is more points per second, longer range, more density, more control, these kinds of things, and simultaneously a lot cheaper. And that that these are probably the roadblocks, right? In software, it's prediction and interactions, and in hardware, it's LiDAR. Are really the things that are needed, I think, to deliver the killer apps for self-driving.
Now, what you said at the end about a lot cheaper, it makes me think on something like, because economics are really important for something to be a scale. And the question is really how far are we from having affordable vehicles that include all the technology that you are mentioning, Warren. And Pekka, I don't know if you are probably more familiar to know the economics behind it, to know basically how far really are we for us to being able to buy a car that is affordable and still have all these things in it.
I don't have good numbers, but I mean, for robotaxis, the budget is just on different level. So if we take a concrete example on how things are proceeding now on the level 2 area, so GM has been in the market with the Super Cruise now for a couple of years, and they just introduced the next generation Ultra Cruise, which will start to trickle down from the highest end. So kind of these are coming, but it's still the cost, and with the kind of high volume vehicles, you typically don't afford for all those sensors, for all those computing capability. Whether level 3 will be there in the next generation of the Ultra Cruise for GM to be seen. But that's a challenge.
There have been several, looking at it from a slightly different perspective, there have been several consumer-facing surveys asking the question from the consumer, what are you prepared to pay for these features? And I'm thinking specifically of one that was conducted by AAA, and all of them come to the same point. The consumer is not prepared to pay anything more than between $250 and $500 for whatever it is. You know, that is the limit of what they perceive. There doesn't seem to be a value versus cost. That is what I'm prepared to pay and no more. And I think if we're talking about the cost of technology, Warren, I think we're some way off of that, even using, the flash LiDAR, I think and cameras, I think we're way off of that still.
Yeah, these are good points. Back to the cell phone analogy, I'm reminded in 2006, I was engaged to my wife.
The same thing now.
Right? But I was engaged to my wife in 2006, and my wife had never had a cell phone, but we were going to be separated and living in different states. So I absolutely 100% wanted a way to talk to her whenever I wanted to talk to her, right? So we went down to the T-Mobile store, and we looked around the phones, and I'm like, boy, $100 for a cell phone, I don't know, right? Maybe we want to get the cheaper one, right? Of course, I ended up shelling out the $100 for the more expensive one, right? But it was a few years later, and we're happy to spend $500, $1,000 on a cell phone, right? We happily drop that these days. And the reality is that cell phones started providing services that we never imagined, or at least didn't internalize emotionally, how beneficial it would be. If, for example, you could, in fact, offer someone, hey, on any U.S. highway, you can fall asleep, right? And we'll wake you up when we get to the next exit. I would imagine that a lot of customers would happily drop $1,000 for that. And in fact, we can see with Tesla's FSD, people willing to drop significant amounts of money just for the possibility of such a product. And so but when we get back to the hardware, I think with LiDAR, there's several different approaches. It's not 100% clear which one will win, but almost all the approaches to really bring down the cost while improving performance in LiDAR is following the same trend that camera and radar did. And that is, it needs to move less and less from discrete components and more to integrated silicon. Now, there's a few different approaches to that. You could have a flash LiDAR, right? Like Conti or Sense Photonics' approach to 2D flash LiDAR. There's a 1D flash LiDAR that Ouster is attempting, right? And there are quite a few there are quite a few others that are trying to build scanning lasers, so non-flash, right? But also based in silicon. Insight Photonics, where I'm at, this is certainly what we're trying to do. Others like Ava are attempting a similar approach, or Baraha. So I think everyone is seeing this. And the good news is that for both camera and radar, this worked fabulously, right? Now, the particulars of how you implement that in silicon, that's still debatable. But the fact that silicon can both dramatically improve performance while simultaneously dramatically reducing cost, it has been proven in multiple industries before, and I expect it to happen again in LiDAR.
Now, Warren, I just want to use this topic to jump into the next one, because you mentioned before that, yes, hardware-wise, we have a lot done, and there is a lot that can be used now, and the price is going down. But you also mentioned something very interesting. The problem is all the development on software related to prediction, like the car is actually predicted properly. And I think that this might be really important for safety, and of course, that would impact regulations. So let's jump into the topic of regulations that we just started now. And Pekka and Peter, you mentioned a little bit about that before. My question is, how much of the regulation and regulatory framework today depends on advancements in the area that Warren was mentioning about prediction, or if it's not related at all, what might be the main reasons why regulation that doesn't move faster on autonomous vehicles?
I guess regulation is let's say technology agnostic. So it's a kind of the regulation is there for the safety, and then which will be the means to achieve the safety is then kind of result. The way to let's say advance with the regulation is to be able to meet the safety of the manual driving. It's there will be business and kind of commercial targets for that, creating business, creating jobs, these kind of things, and then the combination of these. But Germany is kind of, they're willing to pave the way with the regulation, and therefore they took the first steps there, become level 3. California has been also pretty liberal regarding robotaxis, so that's an enabler. But there is no possibility for accidents still. So then the question is, how will the insurances be there? Who will in the end have the responsibility?
That's an interesting question. What do you guys think?
Let me comment on the regulation before we jump to insurance again. There's certainly improvements that can be had, but certainly in the U.S., where I'm more familiar with, and I believe I've seen similar things elsewhere, I actually believe that the U.S. regulatory agencies, both at the state and at the federal level, have been pretty thoughtful on these matters. What we're seeing are regulatory agencies that are clear-eyed and open about the fact that they cannot be at the cutting edge, right? You can't regulate what is not yet envisioned, what is not yet created, right?
Right.
And I think the regulatory agencies have been clear of that, but they've also recognized a regulatory need to protect the public, right? Who is in fact being exposed to these technologies, right? And their safety. When accidents have occurred, it is my opinion that regulatory agencies in the U.S. at least have acted swiftly, right? And dramatically even, right? An example being Uber being pulled from all road testing from all states basically for over a year before they'd come back, right? We can argue as to whether or not they're being responsive enough around Tesla, but they have in fact been acting. They've been collecting data, they've been gathering it. In California, for example, there is a process in order to register to perform these, and this allows oversight. They've built mechanisms in order to require reporting of information, so they can keep tabs on where the experiments are happening, what the experiments are, why they're conducting them, what the outputs are like. And that not only protects the public today, but it also gives the government the needed tentacles in order to grow along with the technology, but without restraining it. Now, you do need a license in order to do full self-driving in California, but they did not build a 1,000-page checklist of everything you need to test it, because how could they test a technology that does not yet exist? How can you make a test for a technology that does not yet exist? But they do, in fact, require the technology companies to self-validate, to submit that validation, and to stand behind it in a legal way.
That's a good point. Now, you mentioned all these difficulties for testing. When something happens, there is all this noise about it, and governments try to stop the actual physical testing because of the issues that could be there. But there are other ways too. And I would like to ask Peter about this, because Peter, I think you have written about this topic, about digital twins and the potential to use digital twins to test autonomous vehicles and probably go around those limitations that government could put in physical testing. Could you please comment something about that, Peter?
I think it's a wider scope than merely regulation. Now, to actually prove the technology is safe, you need to do millions of miles. There is no substitute for it, and that ties in very much with what Warren was talking about, the regulation and regulators giving the developers scope and opportunity within a safe framework to continue working. So instead of taking a vehicle and putting it on the road and doing 24-hour drives to build up that mileage, you can actually build a digital twin of the environment, which Waymo have done with their metrics, and you can test your vehicle to a certain degree, to a fairly well-tuned system before you actually take it into either a test track or take it out onto a public road. So simulation and digital twinning, I think, is it's part of the whole development process, and an important part that cuts down the time. I mean, at the end of the day, we want to save lives. So the quicker we can roll out something, even if it's not perfect, if it's 99% perfect, it's going to save thousands of lives compared to the one or two that the edge cases will not be able to save. And this is just one more tool in the toolbox to get this technology out there.
And you're hitting the nail. I mean, Tesla have a huge benefit on their test fleet collecting data. I mean, the enormous amount of data they can use, analyze. I mean, that's their cutting edge.
Absolutely.
Speaking of Waymo, now, I'm not associated with Waymo. I don't work for Waymo. I have never worked for Waymo.
Disclaimer there.
Disclaimer.
But I do believe that Waymo's published safety case, their safety reports, are the gold standard for robotaxis today. They've done a truly stellar job. Mind you, without a government requirement to do so. To publish, all of their accidents and their safety case and why they believe that the vehicle is safe enough to be on public roads in a really powerful way. That I would urge all other L4 teams to copy that lead.
That's interesting. Now, I don't know if we actually answered the question about insurance and who's at fault that some of these happen. Like, we are putting so much technology in cars now, and we hope that one day, I hope that one day I can actually read in my commuting to work. My commuting is about 45 minutes, so it would be fantastic. But if something happens, and who's at fault? And I think we have talked about this topic in our previous webinars of this series. And I think that it was mentioned also of those critical moments where the car releases the control to the human, those few seconds. Plus, I mean, when the car has the control too, like how is that addressed? Like who would be on fault if something happens during those times?
My belief is that this topic, and also we discussed earlier regarding how to be able to pay for those hardware, etc. So you will need new business models. I mean, with the cell phones, we are used to buy apps and we are used to have subscriptions, and I mean that kind of business models. But still, regarding most of the vehicles, you buy it and then you use it. Regarding the autonomous driving applications, Volkswagen is planning to have options. I mean, you could then subscribe to options and use those. Regarding insurance, I mean, why not to have an insurance included in the let's say option pricing? So kind of something needs to be done in a new way, because otherwise the kind of cost side will be a gating factor, and that's not the interest of the industry. That's not in the interest of these, let's say, people who want to get these new things, let's say, to use these, to sleep while they are driving, while the car is driving.
So in terms of responsibility and insurance, this is ultimately a legal question, and different regions will come to different answers on this. So if we put aside the legal questions, because I'm not a lawyer and I don't play one on TV, I think if we think about it at an intuitive level, right? And there needs to be an intuitive level because the person in the car needs a strong intuition for if it's their fault or not, right? And this will affect their behavior. And so first, when we release a product, any product, it needs to be absolutely 100% clear and not buried somewhere behind in the user manual, right? It needs to be absolutely clear in the marketing of the product. If when you're using this product, are you responsible? Are you the responsible driver, or is the car responsible? And this needs to be very clear to the user at the sub-second level, right? So if you're going to switch back and forth, you're going to need something, right, like a light that says if you are responsible. It has to be super simple. It has to be super clear and unequivocal. Now, if it is the car's fault, then it probably gets a little fuzzy from a legalistic standpoint, right? Well, did you perform the proper maintenance, right? Is it the car which you own, right? And you're responsible because it's your car, or is it you purchased this car and it was faulty, right? Or the OEM actually put all the blame on the tier one, right? There are those legalistic questions, and I think those follow through similarly as they have in previous cases. But the key, I think, is we have to be really clear at the marketing level who is responsible. And then if you get to the L4 level, I mean, I don't know, but my guess is actually that they come up with some form of self-insurance, right? If you own 100 vehicles, you're operating 100,000 vehicles, you're operating 100,000 vehicles, maybe you pay someone else to bear that risk for you, right? But they're basically going to work for you. It'll look a lot like self-insurance.
Yeah, I wonder if there will be a need to change the driving license requirements. Probably to get your driving license, now you have to show some skills on using ADAS and how to deal with autonomy.
I think definitely. If you look at level 3, I mean, what Warren was talking about right now, clarity. We don't have any form of standardization. I can't get into car A and it's got a level 2 that I know it's got this suite of level 2. So it's got a forward collision warning, it's got autonomous emergency braking, and that's level 1. Level 2. From a consumer's point of view, how does he know what this vehicle is going to do? And the next step from that is once he does, then you can start talking about, insurance and bringing down the cost, because up until then, I think the consumer is going to be very confused about this technology.
Maybe I could add a story to that. So me, I write self-driving software for a living, right? This is my full-time job. But at Thanksgiving, my family and I went to my sister's wedding, and we rented a car, this massive Ford. And it clearly, per the buttons, had different ADAS features, but I didn't fully understand them, right? Here I was just sitting in a rental car. I don't even know where the car manual was, right? And I turned cruise control on, and I don't know. Does this slow down for the car in front of me or not? And I'm actually put in this awkward situation where in order to understand its limitations, I need to test it, right? In the city that I've never been before, right? On a car that I've never been before. I can't even figure out where the windshield wipers are, right? And now I'm trying to wonder, is this going to slow down for the car in front of me, or do I have to do that?
Yeah, that's very interesting. Now, talking about that, Pekka, this is a question that I've been thinking now based on what Peter and Warren mentioned. What potential business opportunities are there for OEMs then to kind of change the way it is now? Because now it's just sell the car and that's it. How do you see the future will be on business opportunities?
There must be something different. I mean, services, subscriptions could be like time-based, so that you subscribe to your level 3 for 1 month when you use more, or for, let's say when you need for business purposes. That's the way to go. However, it's very different compared to the kind of traditional old business model, and it's not going to be easy. Tesla has been doing something there. Other ones will follow, but I mean, probably we will see different type of trials. I mean, different OEMs will try different ways to do that. They need to educate the customer. They need to educate the public that people know what they want and how they can get those features to use.
Pekka, I don't disagree with you. In fact, I probably agree with you. I'm just curious from your viewpoint, why is it that you believe that this probably has to go to some form of subscription model?
The automotive industry is so pushed with the cost, and I mean, now when the OEMs are creating the capabilities to do all the updates, to do kind of smaller step development compared to like traditional every 3 or let's say 3-4 year steps. So that's kind of, let's say it's a natural way to go forward in subscriptions and kind of add more features to your vehicle when it is getting more mature. May say so.
I see. So let me just repeat that back to you, make sure I get it. So someone's going to buy a vehicle, and they're going to want it to last for 10 or 15 years. And over that 10 or 15 years, they're also going to want software updates and map updates and interface updates and all of these things. And so because you're providing benefit across those 15 years, you would expect that, and that benefit is unknown at the beginning of those 15 years, right? That some form of continuous payment maps with the continuous benefit being provided.
Exactly. And I mean, today, the development is done in kind of features. I mean, level 3 or level 2, I mean, those are kind of big things, but those are split into features. And then OEMs bring one feature at a time, so that the kind of whole experience becomes more complete. I mean, if your customer purchased the car 2 years ago, the hardware is there. Did the customer already pay for that, or is for the future? I mean, it just brings the flexibility, and then also enables new business models, new kind of new applications, new ways of making money.
Yeah, but how is it? Go ahead, Peter. Sorry.
To tie in with what Pekka and Warren are saying, maybe 2 points. One is definitely monetization of systems is the way that the OEM and the franchise is going to be able to continue some form of income as we move further down. Service workshops are going to be less and less busy. There's going to be less and less revenue coming in from them. So some form of subscription, whether it's for traffic, whether it's for FSD, whatever that is, monetizing that is going to be important. The other point is, I think we're talking about a transition period. I mean, at the end of the day, we want to get to the point, we want to cut out that 94% of the 1.2 million people that die on the roads as a result of human error. So at the end of the day, we want every single vehicle to be a level 5 fully self-driving vehicle. And at that point in time, subscription is not an option. That is the way the vehicle comes. It's got all of that built in, and that may be 30 years, it may be 40 years away. But I think ultimately that is the direction that we're going.
That's like a good point. Now the question is, how easy is to retrofit the hardware that is already out there and to update it? I mean, software might be easier, but hardware, like how easy is to do that? Like you see, cell phones is simpler. It has a very short life cycle, but an automobile has a longer life cycle. Well, at least in my case, I know I have friends that change it every year. That's not me. But how is that going to work?
This is difficult enough that I don't foresee a clear, viable plan for this on the long term. Now, certainly, there's some exceptions. Mobileye got their start in the aftermarket market, and they did well with that, although with much simpler products. If we look at other aftermarket things, like if you look at Comma AI, they build a Super Cruise-like product aftermarket. But boy, I'll give you an example. I was talking to someone who doesn't know anything about software, right? He's never written a line of software in his code in his life. He doesn't understand how these systems work at all. But he wanted to upfit his Prius, so he ordered the Comma AI hardware on the internet, and then it showed up. And then they pointed him to an open source project on the internet where he was expected to download software and install it on the hardware himself, and then install this on his Prius for 15 minutes, right? And because no one is willing to accept the liability, right? Comma AI is going to sell the hardware, and you have to go get the software yourself because they don't want to be responsible for that, right? And you make it this open source project because, boy, who are you going to sue, right? And then you have this completely untrained individual, right, who is now using this to drive across the country on the highways without any proper testing at any stage, right? And the idea that I'm going to bring in my 85 Buick, right, or my Knight Rider, and someone at the shop is just going to screw on a few things, and this is going to be properly validated and testable is just, we're all optimistic because we work on self-driving cars, but this feels
not that optimistic,
excessively so, right?
I mean, this is optimism in a bottle.
Go ahead, Pekka.
I fully agree. I mean, there's no way. I mean, just taking legislation, insurances, all that. I mean, also outside the vehicle itself, it's not going to happen in wide scale.
Yeah. Now, unfortunately, the time is limited. We have reached almost the time that we have for this discussion. I honestly think that we could talk about this the whole day. We have 3 minutes left. And as we did from the previous sessions, I want each of you to give me 1 minute short statement of how you see these technologies are going to be by 2030. And we're going to start with Warren, then Pekka, and then Peter.
So, I left my crystal ball in the other room. But
this is your opinion, yes, your dream.
Yeah, so 2030. So we're looking at 8 years from now. Let's be as optimistic as we can, right? We're going to live in a beautiful utopia where we spend most of our time in the metaverse, and some of it that we have to spend in our cars. we're not spending driving. The number of fatalities have really dropped in developing countries, and we're beginning to in the developed countries, and we're beginning to export that to because of costs and other reasons elsewhere.
Yeah.
And ultimately, by 2040, we have saved millions of lives.
Sounds great. What about you, Pekka?
I'm not maybe able to be that futuristic, bit more kind of concrete. So continuing the technology development. So the kind of level 2 plus cars are there. The kind of wider range of the sellable cars will have these level 2 plus features. I believe in 2030 there will be level 3 cars, kind of let's say volume production, but then those will be from the, let's say, the highest end of the fleet. So kind of starting there and then gradually trickling down.
Sounds great. And Peter?
I would tend to agree with Pekka. I think level 3, 2030, 2032, 2033, I think that's doable. If we're looking at higher levels, I just quote the Gartner hype cycle, which puts self-driving firmly on the slope of disillusionment and putting it at least 10 years away.
Sounds great. Well, thank you, Peter, Pekka, and Warren, for this fantastic conversation. As I said, we could actually chat about this for another 45 minutes, even more. But now is the turn of our audience to send their questions. We have received a few already, and we will jump now into a Q&A session.
Gentlemen, thank you all for that great discussion. As Edgar mentioned, we are going to move into the question and answer session. If you have a question for us today, please go ahead and enter it into the Q&A window and hit submit. We will get to as many questions as we can today. If we do not have time for your question, do not worry. We will reach out to you following today's session. So Edgar, I'm going to pass things back to you and the group to answer some of our attendees' questions.
So, well, we're back for the Q&A sessions, and we have received already a few questions here that we selected a few of them just to start answering now. The first of these ones is, I think this one could go to Warren, is how long until we see vehicles where the driver is completely removed from decision making? And what will be the driver's responsibility at this time?
Yeah, that's a good question. So if you're completely removing the driver, let me start with the last question first. If you're completely removing the driver, clearly it can't be the driver's responsibility, right? Almost definitionally. And now, when will we see cars without a driver? We see them today. Waymo is doing this already in the Phoenix Chandler area. And they've been doing it for years, and it seems to be going very well. Cruise has recently started doing this in San Francisco. It's a smaller demo pilot, similar to how Waymo started in Chandler a few years ago. And so, and in China, we're seeing several of these. So we are already seeing today vehicles without drivers in them. Now, there's probably a question behind that question, right? And that is, when do they get to do this, and when does this get to be part of their daily lives? And this depends on a few different paths. So one path, earlier in the session, we talked about how, from a software perspective, perception has made a ton of progress, and the holdups are about prediction and interactions. This means that several teams are switching to highway freight. On highways, it's much more structured. There's a much smaller set of behaviors, a smaller set of kinds of actors you could run into. And so we'll see this sooner. The real holdup to seeing that in your own personal vehicle, being able to go on the highway and go to sleep, for example, is, like we talked about, hardware. The unfortunate part of this, in terms of timing, is that having talked to all of the sensor companies basically in this space, There's only one LiDAR team that I believe is targeting both the cost and the performance necessary in order to do that. So there's a high variance there, right? If there were 10 teams trying to do this and targeting the right things, then we would feel pretty good about one of them achieving them. But since there's only one, there's a certain amount of risk there. The other route is the robotaxi route. And the question is, well, how quickly can a Waymo or a Cruise scale to the point where this makes a considerable impact on your personal life? And unfortunately, there's quite a bit of uncertainty around this as well. Waymo's been in Phoenix for quite a few years now, and the fact that they have not scaled to anywhere else yet, I think, illustrates the challenges here. And Cruise is still doing it too small to get a really clear signal. They also have yet to release a comprehensive safety report in the same way that Waymo has. So it's years still.
Got it. Thank you, Warren. Now, there is another question. I don't think we covered the topic of cybersecurity in our call, but this question is very interesting. And I wonder if Peter, if you could help us with that. The question said, what are the most vulnerable entry points for potential hackers? And how can engineers reduce this risk?
Yeah, I think in the world that we live today, we're always going to get bad actors. But when it comes to self-driving autonomous vehicles, obviously the risk or the consequences of bad actors are really bad. So the attack surfaces, the common attack surface, from a hacker's point of view, utopia has to be direct access to the vehicle, and you get in through the onboard diagnostics port, and you've got access to the CAN bus, and you can fiddle with whatever system you want in whichever way you want. Then you've got call it the accessories, so people with cell phones. That is another attack surface. So you can access it via Bluetooth. You can, once again, vehicle is connected. All systems are connected via CAN bus, so you can access any system. The same goes for infotainment. You can access it. Once you're in the infotainment system, you get into the vehicle. But even because vehicles are connected with Internet of Things, you could even use a household appliance. So it's conceivable. I mean, you could use a smart refrigerator. If you can hack the refrigerator, get onto the Internet of Things, and you could have access to the vehicle. So there are many ways of controlling this. The one way is obviously making sure that the cloud is secure and installing security systems around that. The other one is a lot of companies are starting to look at using blockchain to actually have a secure, decentralized system that is encrypted.
Those are really good points. Thank you, Peter. There is another question that I think could go to you, Pekka. And it says, what responsibilities will OEMs and tier suppliers have to keep vehicle technologies up to date? And how will this be done?
That's an interesting one. I guess this could be divided into two parts. So there's the hardware part, and then there's the software part. Starting with the hardware, you could imagine that, let's say, the different sensors needs to have the safety mechanisms to diagnose whether they are in good shape or not. Of course, if something fails, that needs to be fixed, and maybe that could mean that some features of applications level 3 area would not be usable before it has been fixed. And then regarding software, OTA. Software updates over the air. That's the way to go. Of course, then at a certain point there starts to be question that, let's say, how far the kind of old or existing hardware can support for the new features. So probably, there will be kind of features will be fixed, and then maybe some minor updates will be done, but not that much further development. I guess the kind of, let's say, the cellular world today and these kind of things will kind of show practical examples how these will happen in practice.
Oh, thank you very much, Pekka. And we have a last question that, is partly technical, I think partly philosophical, so I don't know whoever of you want to answer it. It says, some consumers are wary that automated driving is as trustworthy or moral as a human driver. Are there any technology developments that could ease their concerns?
Yeah, so this is a fun one. Let me put on my philosopher hat. It's really tiny. I'm an engineer. But if I put on my philosopher hat, I would submit that robots don't have values or morals in the same way that you or I do. So I'm going to have to try to guess a little at what the questioner is asking. And here's an example of what I think the questioner is asking. Years ago, we bought our first Roomba, right? So here's one of the first robots that can move around and interact with the environment in my home. And we have a problem. Our problem is that we have a dog who's like 99.9% potty trained, right? But that 0.1%, boy, we were not going to let that Roomba run when we were not in the house, because you just Google poop and Roomba and it's just catastrophic, right? So now it isn't that Roomba has different morals or values than me, right? But when it behaved that way, or if it were to behave that way, right, I would feel, it would feel personal, right? I would feel like it was an affront that this robot clearly feels differently about spreading poop all over my floor than I do, right? Now, it is doing no such thing. It is purely following instructions. And so I believe that, it doesn't have morals, it doesn't have values. It has inputs and it has behaviors. And those we give it. And we absolutely 100% have to make sure that these cars don't drag poop all over your carpet. Or it's just not trustworthy, right? It's a different kind of sense of trustworthy. It isn't the same as, I go to the store or I make a deal and I look someone in the eyes and I shake their hand and I decide I can trust this person, right? It's not that kind of trust. It's the kind of trust that I can turn my toaster on and it's not going to burn down my house.
Right. Well, thank you very much, Warren. I wish we had more time to discuss this and other questions that came from our audience, but unfortunately, our time today is over. Thank you very much, Peter, Pekka, and Warren, for these excellent discussions and for your answers, for sharing your ideas, opinions with the audience. To the audience members, thank you for listening and for going through all the series. These series are available on demand at globalspec.com/events. Thank you to our sponsor, Murata. And finally, for globalspec.com, thank you to the million of engineers who have allowed us to connect them with the parts and services they need for project success. And finally, well, now back to Katie.
All right, thank you so much, Edgar. Now, just a few items before we end things today. I would like to say a huge thank you to all of the panelists today and to Edgar for leading our discussion. A special thank you to Murata for sponsoring this Automotive Electronics Roundtable series. Today was the fourth and final session of our series. Thank you all so much for joining us. If you happen to miss any of the sessions, you can visit our series page using the link listed in the resource widget. They are all available for on-demand viewing. And a huge thank you to our audience members for being here with all of us today. Please take a moment to complete the survey, which will appear on your screen at the end of this session. Again, thank you for taking time to attend this Globalspec series, sponsored by Murata. Take care, and we will speak with you soon.